Let's look at a subtopic, a continuation of electrolysis, half-cell equations, writing and balancing. Half-cell equation is used to represent the reaction that happens at the electrodes, that is the anode and the cathode, during electrolysis. It shows what happens when ions gain or lose what? Electrons, right? So let's look at what a half-cell equation entails. In half-cell equation, one electrons are shown as this. The number of atoms of each element must be the same on both sides. The total charge on each side must be the same. Usually 0. Sometimes it can be what? Negative coefficient at both sides of the equation. Let's look at how you can write cathode half-cell equation for the following cations. This is the cathode half-cell equations, writing and balancing. This is a subtopic that you're required to know, especially when you are studying electrolysis. You should know how to write and balance cathode half-cell equations, likewise anode half-cell equations, and finally the net ionic equations, right? So let's start with a cation, sodium ion. This is sodium ion. This sodium ion, and this sodium ion definitely will migrate to the cathode. This one gets to the cathode. The cathode is negatively charged, and this positively charged, unlike charges attract. So when this sodium ion, the cation, gets to the cathode, right, what happens? It is discharged as sodium atom, a neutral element. If you look at why is this one neutral, this one is a charged particle. You look at the number of proton here is more than the number of electron. Here the proton and electron are the same. So when you add them, the net charge is 0. Like proton here is plus 11. Electron here is minus 10. The net charge is plus 1. And you see the plus there. This one, the proton still remains the same, still 11. Electron is minus 11. The net charge here is 0. So this is an atom. All atoms are electrically neutral because the net charge is 0. This is a charged particle. The net charge here is plus 1. So we don't write plus, we just write just ordinary plus. So these are their charges. So look at the number of atoms of sodium. Sodium here is 1, sodium here is 1, right? Then the charges are not balanced. So on the right hand side, the charge here is 0, and here the charge here is plus 1. How do I neutralize this? I need to add electrons. So cations usually gain or remove electrons from the cathode. So sodium will need to gain an electron, right? This electron is from where? The cathode, right? And flowing from the external circuit. Now if you look at this side now, sodium, the net charge here, the charge here is for sodium is plus 1, the electron is minus 1, right? That gives you 0. Here is 0. So the left hand side charge and the right hand charge for these particles are now the same, 0, 0. So this is when the number of atoms are the same and the total charge or the total charge on each side are the same or equal. That means it is balanced. So this is the cathode half-cell equation for sodium. This very one is how you write it. Na plus plus an electron gives you this. So this one is now formed at the cathode, produced at the cathode. So when you discharge sodium ion by gaining an electron equal to the oxidation number, it will produce what? Sodium what? Atom. Let's look at others like calcium. Calcium ion is a cation, so it will be attracted by the what? Cathode, and definitely produce what? Calcium. Now the number of atoms are the same, so it just need an electron. This one need to gain an electron, so it's going to gain 2 electrons, right? And that will give you this. So this is the half-cell equation. If you look at the number of atoms, is 1 is 1. The charge here for calcium ion is +2. Electron is always minus, so it's negative what? 2. So that gives you 0. Here is what? 0. This is, if you see an atom that is not charged, there's neither plus or minus, that means this one is electrically what? Neutral. So this electrically what? Neutral. So we'll move on to the next one now. That is hydrogen ion. Hydrogen ion. It will discharge as what? Hydrogen gas. So if you look at this hydrogen ion that gets to the cathode, this is what? Hydrogen gas. Now the hydrogen atom here is 1 and here is 2. So we'll put 2 here. The number of atoms here, there is a coefficient here is 2, here is a subscript is 2. They are both the same. So 2 hydrogen atom, 2 hydrogen atom. Now the charges are not the same. Here it is what? 0. Right? Here is what? +2. So what it needs, that it needs 2 electrons to balance that. So it needs to accept 2 electrons. So the net charge here +2 minus 2 gives you 0. Here is already what? 0. It's not combined. It's a neutral what? Element on an atom. So this is the half-cell equation for the discharge of what? Hydrogen at the what? Cathode. At the what? Cathode. This for hydrogen, right? Hydrogen what? Ion being discharged at the what? Cathode as what? Hydrogen what? Gas. And if you look at hydrogen closely, you see that the only gas you find around the cathode is what? Hydrogen what? Gas. And hydrogen ion is the only cation that is not a metal, right? It's not a metal. It gets to the cathode and is discharged as hydrogen what? Gas. The rest are metals when they are discharged, but this is a gas, right? So this, if you look at a particular question, especially when you look at the cathode, and you see bubbles of gas. This is a cathode. This gas, the bubbles, signifies hydrogen what? Gas. Hydrogen what? Gas. Take note of that. So if you look at the whole trend now, is like cations, when they get to the cathode, they always gain electron. Electron what? Gain. Electron gain. Electron gain. So they are now reduced to their corresponding what? Element or molecules, right? These are atoms, these are what? Molecules, right? So all of the half-cell equation, current at the cathode shows electron being gained. So they all show reduction. Reduction is taking place at the what? Cathode. If you look at reduction, we have an acronym RIG. RIG is reduction. Is gain of what? Electrons, right? Electron. So when electrons are gained by cations, they become what? Reduced to their corresponding what? Element. So don't forget this. This will help you to understand this cation discharge at the what? Cathode. So this is the cathode has equations for some what? Cations. For some cations. You can practice the others, like aluminum ion, ion 2 ion, and ion 3 ion. I wish you guys all the best, and after knowing this, you should also learn how to write and balance anode half-cell equations. Anode half-cell equations.